Hello. In this tutorial, you'll learn how to professionally train a voice model from scratch. Whether it's a singer, an artist, a voice actor, or even your friend, it doesn't matter. After watching this tutorial, you'll be able to create a flawless voice model with the highest possible quality, one that can mimic the person's voice so accurately that it sounds just like them. Let's dive right into the tutorial. First, I'll talk about the system requirements. There are two scenarios. Either your computer is powerful, or it's not. If your computer is powerful, say you have an RTX 3060, 3070, or a better graphics card, you can easily train your voice model offline using the RVC software. If your computer isn't powerful, you'll need to train the voice model online using Google Colab. Don't worry, this method is also completely free, and I'll provide a full step-by-step guide for you. So, it doesn't matter whether your computer is powerful or weak. Either way, you'll be able to train your voice model with ease. This video is second part of the voice conversion tutorial series. You can watch the first part of the tutorial on this page, and I've added the link in the description. In the first part, we covered how to install the RVC software, explored voice models, and got familiar with the RVC settings. In this part, we'll dive into the complete process of training a voice model from start to finish. Let's start by assuming you have a powerful computer, like an NVIDIA 3060 or 3070 graphics card. Even if your graphics card is slightly less powerful, like a 3050, that's okay. It'll just take a bit longer. If your system is powerful, simply open the RVC software. Click on Go Web, and the RVC interface will launch. While it's loading, let me share some important tips with you. To achieve high-quality audio output, there are a few key points you need to keep in mind. Similarity between input and model voice. The input voice and the voice model should have some level of similarity. For example, imagine you've trained a voice model for Bruno Mars using his songs. Then you use Eminem's raw voice as input and expect a high-quality rap in Eminem's voice. While you'll get an output, it won't be the best possible quality and may sound a bit off. Language consistency. The language of your input audio and the voice model must match to achieve the highest quality. For instance, if your input and audio file are in English, it's best to use a model trained on English-speaking voices. Those were the initial key points. Now, let's continue with the tutorial. Along the way, I'll share additional tips. If you want to use the voice of a singer, you'll first need clear and raw vocals of that singer. Start by downloading a few high-quality songs in a similar style. Next, you need to separate the vocals from the music. To do this, go to this section of the RVC software. Here you'll need to provide the software with the location of the music file. For example, I'll select a song I've already downloaded. You can simply drag and drop the song file into this section. No need to manually type its location. There are two empty fields here where you specify where to save the audio output. Create a folder. Name it something like Output or any name you like. Copy its path and paste it here. You'll notice one field says Vocals, which refers to the isolated vocals of the singer, and the other field asks where to save the remaining parts, like the instrumental track. I'll set both to save in the same folder. Next, it asks for the output format. To achieve the best quality, you can use one of these two formats, WAV or another high-quality format. While MP3 is an option, it slightly reduces the audio quality. On the other hand, these two formats maintain high quality. I'll choose WAV for this tutorial. Here it says Model. These are the models that will help us separate the vocals. There are several models available for this purpose, such as HP2, HP3, and HP5. Based on my experience, HP2 usually provides the best quality, meaning it does a better job of isolating the singer's voice from the music. So I'll select HP2. Here you can also find some additional notes. For instance, it mentions that HP3 might preserve the vocals slightly better, but in some cases, it might miss certain parts, and parts of the instrumental music might still be audible alongside the vocals. I recommend starting with HP2 to generate an output, then trying HP3 and HP5 to see which gives you the best results. Personally, I almost always use HP2. As you can see, it quickly separated the vocals. Let me try using a higher quality audio file. One more tip. Make sure to place your audio file in a specific, easy-to-find location like your desktop, and simplify the file name. Avoid special characters like parentheses or dashes in the file name. Once you've done that, drag the file into this section. Look, if I want to delete this file right now, nothing shows up. This happens because of a bug in my browser, and it might exist in your browser too. All you need to do is come here. You see the mouse pointer icon is a hand. Below this text, there's a delete button. Click on it and the file will close. Now I'll drag it back in and click on Convert. Let's wait a few moments for the track to process. Here, you can see how much progress it's made. Alright, it's almost done. Let me open this vocal file. As you saw, the sound was separated well, but there was one issue. The audio had some reverb. We need raw, unprocessed sound without any effects. Now, what is reverb? Let me explain. In music, there are several effects used to add depth to the sound. One of them is reverb. Another is echo, along with many others. Reverb refers to what happens when you make a sound, and it spreads in all directions. When this sound hits various surfaces and then reaches the listener, it creates a delay before the original sound fades away. For example, think of the sound you hear in a bathroom. When you sing, the sound bounces off the walls and other surfaces before coming back to your ears, giving your voice a sense of depth. So the sound you hear in a bathroom is essentially a natural reverb effect, which we artificially recreate on computers. Now let's talk about echo. When we speak, if our sound wave hits a distant object and takes longer to return to the listener, that's what we call an echo. Alright, let's move on with the tutorial. As you can see, we've separated the sound. Let me open it now. It's clear that the audio still has reverb. Now let's remove this reverb. I'll take the same vocal output file we created earlier, drag it back into the software, and place it in the input section. If the previous file is still open, we close it like this and replace it with the new file. Next, we have several models here for removing reverb and echo. I'll select this one, which removes both echo and reverb. Now look at these two options as well. Try them out and see which one gives you a better output. I'll choose this one since it usually works well for me. Next, I'll create a separate folder in the same output directory so it doesn't mix with the others. I'll name it something like de-echo or de-reverb. Then I copy the folder's path and paste it into these two fields here. Alright, now I'll hit process and it will start working. Here you can also track the progress of the process. After it's done, the software will display a message here. Alright, it's finished. Sometimes the software labels the files incorrectly. For example, here it says vocal for the top one and instrumental for the bottom. However, the top one might actually be the instrumental, and this mistake happens occasionally. This one is our vocal. By now, you've learned what reverb and echo are and why we need to remove them. We need a clean, dry voice with no effects. Now you'll need to combine it with a few other audio clips and create a file that's around 15 minutes long. Also, remove the unnecessary parts. For example, let me open this audio file now. See, this part is just noise. It should be removed. We'll start at second 1, so delete everything before that. For example, here the audio is good, so we'll select it. But here you can hear some effects in the sound, so we'll remove this part. How do we do this removal? You can use any audio editing software to delete unwanted parts. I personally use Adobe Premiere because I'm familiar with it, but there's a lightweight software that can do the same for you. Audacity. Just search for Download Audacity on Google. It's completely free to download and use. Once you've downloaded and installed it, Open the program and drag your audio file into it. Then select the unwanted parts like this and press the delete button. We press play. I will remove this noisy part. Look, this part has effects, so we'll remove it too. Alright, I won't continue further. You can proceed the same way. If we want to get a very good output, we need a clean audio file of the speaker that's about 15 minutes long. Even 5 or 6 minutes can work, but 15 minutes will provide the best possible quality. The audio file should contain the clear voice of the speaker. For instance, this one is 3 minutes. If we want to add more to it, we'll drag the next audio file here, like this. Then we'll align it and add it to the end. Remove the parts you don't need, and from the File menu, click on Export Audio. Choose a location, like my computer or desktop, and export it. It'll take a few moments to process and save the audio file. Steps to prepare a voice dataset. Separate the voice. First, isolate the speaker's voice from the music. Remove reverb and echo. If necessary, clean up the audio by removing any reverb or echo effects. Now, moving on to the next step. I want to create a voice model for a person. Previously, I downloaded an interview of this person from a news website. I separated the audio and extracted about 30 minutes of their speech. Here's the audio file I've prepared. It contains 22 minutes of clean speech from that person. You can do the same with the voice of a dubbing artist, a character in a movie, or even a voice actor for your videos. The process is the same. Important points for editing audio. Don't cut between words. For example, if the person says library, you shouldn't cut in the middle and end up with brary. This will lower the model's quality. Always make cuts where the speech naturally pauses, not just wherever you like. Silent gaps are fine. If the speaker pauses briefly before continuing, don't remove that silence. It won't affect the output. Remove unwanted noise. For instance, if there's background noise or a second person speaking, delete those parts. Now, I have about 20 minutes of audio ready. I'll train a voice model using this dataset. In the context of AI, the files we provide to train a model are called a dataset. This audio file is our dataset. Now I want to train my model using this dataset. It's simple. Just open the tool and go to the Train section. Here, you write the name of your model. For example, I'll name mine RVC Training, but you can name it anything, like the person's name. Next, set the sample rate to 40K. You can choose 48K too. It doesn't make much difference. Leave the true-false option on true. It's necessary for singing, but optional for speech. So I'll leave it on true. Set the version to 2 for better quality and keep the value at 6. Always avoid using the maximum CPU or GPU power, as it can cause errors during processing. Finally, it asks for the folder containing your audio files. I'll create a folder, name it something like Dataset, and make sure the name has no spaces, parentheses, or special characters. Then I'll copy its path and paste it here. Now let's set this to 0. This is used when there are multiple speakers in your audio file, but currently, RVC only supports one voice. Click Process Data to process your dataset. Once it's done, you'll see End Processes. If you have multiple GPUs, you'd need to enter their IDs here. Since we're using one GPU, we can skip this. Next, choose the method for training your model. Use PM if your hardware is weaker. Harvest gives good quality but is slower. DIO is for speech only. RMVPE is great for all purposes, and the last option is a modified version for faster GPU processing. Click Feature Extraction and wait until it's done. Once you see all features done, it's complete. Now on to training. Here's an important setting. Epochs. One epoch processes your entire dataset once. By default, it's set to 20, but if you want professional results, use a clean 15 to 30-minute audio file. For 15 minutes, set it to 100 epochs. For shorter files like 5 to 6 minutes, use 200 epochs. While 20 epochs might give decent results, a clean dataset matters more than the number of epochs. A poor dataset can ruin quality. even with 1,000 epochs. Ensure your audio is clear, without interruptions or poor quality. To save progress during training, use the save frequency setting. For example, if set to 10, the program saves every 10 epochs. This helps resume training from the last saved point if interrupted. Finally, there's batch size per GPU. This determines how many small 2 to 5 second audio samples are processed at a time. For a 3070 GPU with 8GB VRAM, 8 works best. For a 3060, use 6. For a 3090, use 10. Experiment to find the optimal number for your GPU, but if unsure, stick with the default, which is 4. It says here that only the last checkpoint from the training data will be saved to your disk. Why? Because this prevents your disk space from filling up. What does that mean? I mentioned here that every 5 steps it will save all the training data. Once it reaches step 10, it will save again. But if this option is set to yes, it will only keep the last step reached and delete the previous ones to save disk space. If you have plenty of storage like I do, set it to no. Each training file won't exceed 10 or 12 gigabytes. Also, don't get it wrong, the output PTH file will only be between 50 to 200 megabytes. For example, if you set 100 epochs, tell it to save every 20 epochs. I set this to 20 for this tutorial, and for this option, I tell it to save every 5 epochs. There's another point mentioned here. If your dataset file is small, for example, the audio file you're using is less than 10 minutes long, I load the entire dataset file into the GPU memory. This results in faster processing. However, if your file is larger, it can have the opposite effect, slowing down your work, and it might even freeze your computer. In any case, I recommend keeping this setting turned off. Another option here says, save a small file model to the wait folder at each save point. In the previous tutorial, I mentioned during the installation of audio models that there's a folder called wait, where we place our .pth models. At every save point, which we defined earlier, it saves the model we've created so far. For example, if it reaches checkpoint 5, it saves the model up to checkpoint 5. You might have set your training epochs to 100, but if you want to test the model at epoch 20 to see if the quality is good enough, you can stop there. For instance, you might achieve excellent quality at epoch 30, and then there's no need to proceed to 100 epochs. So we set this to yes, so it saves the model every 5 epochs. I usually set this to 100 and the save interval to 20, meaning it saves every 20 epochs. That's it, we've covered everything. Look, there are 3 buttons here. Just press this button and it will handle everything on its own. You don't need to work with the other buttons. Click this one to start the processing. Keep in mind that you must not close the command file. Closing it will shut down the software. What you see in the browser is just a UI user interface that allows you to interact with the software without needing to manually type commands in the HUMPA. Sometimes, when you click on one-click training, you might encounter an error. In that case, close the RVC software completely, reopen it, and follow the same steps. If you encounter any other errors, write them in the comments, and I'll respond to help you. As you can see, the dataset processing has started. Each epoch represents one complete processing of the dataset. It says that the first epoch took 58 seconds. Usually, the first epoch takes the longest. The second epoch took 37 seconds. We have 20 epochs, right? On average, each epoch is expected to take 37 seconds. So if we multiply 20 by 37, we get 740 seconds. Dividing 740 seconds by 60 gives us 12 minutes to complete the 20 epochs. Now, if it were 100 epochs, it would take approximately an hour to produce a high-quality audio model. While this processing continues, I'll explain something. Let's say the software closes for any reason, like a power outage, accidental closure, or anything else. What happens then? I've set it to save the checkpoint every 5 steps. For example, if it's at step 4 and the software closes before reaching step 5, all processing will be lost. However, once it reaches step 5, the checkpoint will be saved, and it will note that it saved up to checkpoint 5. Now, as you can see, it has saved the checkpoint because I enabled this option. If I refresh the list, a new model will appear. The model's name will be listed, and next to it, it will say that it's saved at the 5th epoch. You can now test it, as I mentioned earlier. This is for testing purposes. Now, let's assume the software closes. What should you do? It's straightforward. Simply enter the same previous model name here, set the dataset path, and don't click on these options. Leave them as they were initially. The other settings can be whatever you like. It doesn't matter what they were before. Set the number of epochs you want, and set this part to 8, or leave it as it was. Once everything is set, click on One-Click Training to continue the process. One more important point. Let's say the process didn't close, and the 20 epochs completed successfully. If you want to extend it to 100 epochs, you can follow the same steps I just mentioned. Change the epoch count from 20 to 100, and click One-Click Training. It will resume from the 20th epoch. So there's no need to worry if you initially set a lower epoch count, like 100, and later want to extend it to 300. It will resume from where it left off without any issues. I can confidently say I've explained 99% of what you need to train a model in this tutorial. If I missed anything or you have any questions, feel free to ask in the comments. Our processing has reached the 12th epoch, meaning the entire dataset has been processed 12 times so far. Now, if I go here and click on Refresh List, you'll see 2 trained files available, one at epoch 10 and another at epoch 5. Where are they stored? Inside the RVC folder under the Assets folder, then the Weights folder. You can see these 2 files have been added here. Alright, I'll pause the video until the 20 epochs are completed. The training is now finished. You can see it says, Checkpoint 20. Your model has been saved. Epoch 20 is complete, and training is done. If I refresh here, you'll notice it has saved checkpoints at epochs 5, 10, 15, and 20. Your final model is the last one. If I click on it, the index is automatically added. The quality of this 20 epoch model is quite good because I used a high-quality dataset. However, to achieve the best quality, you'll need at least 100 epochs. Make sure to subscribe to the channel. In the next tutorial, I'll teach you how to train using Google Colab, which is useful if you have a weak system.